All right, United. So welcome to part A to C of your revision notes for our chemistry unit. So basically we're going to have a look at the three different components on your first revision exam, and we'll look at each of the sections while you guys are filling out your worksheets. So the first part is chemical and physical change. So physical change is when the matter changes its properties, but it still stays the same. So for example, water, H2O, when it's frozen, still H2O. When it's a gas, it's still H2O. In terms of chemical change, it occurs when new compounds are formed or elements are released, all with different properties. And so, for example, you've been doing neutralization, where we have salts formed. That's a new compound. It's a chemical change. Some of our examples of physical change. Obviously, we have the ones to do with our changing of state. So freezing, melting, boiling, condensing, cutting, and things like subliming or depositing. We've also got things like cutting or grinding, bending, blending, and dissolving. Some of our examples of chemical change: combustion, cooking things like eggs, reactions with acids and bases, oxidizing like rusting, decomposing, and digesting. With a chemical change, once a change has happened, it's very, very hard to get it to go back to its original form. Some of the signs of a chemical change: the color may have changed. There may have been a change in temperature. A gas may have been produced or may be a precipitate. You need to classify the following as a chemical change or physical change on your worksheet. So cooking egg, boiling water, melting ice, cutting paper, the reaction that you might have when you set up a fake volcano of vinegar and bicarb soda, burning a match, condensation on the outside of a Coke can, sublimation from when a dry ice goes straight from a solid to a gas, and rusting. Part B, elements, compounds, and mixtures. Elements, compounds, mixtures. Elements made up of one type of atom. Compounds, two or more. And mixtures can either be a mixture of compounds, a mixture of elements, or a mixture of both, but they're not chemically bound. So elements include things on our periodic table, like oxygen. Compounds, chemically joined, like H2O. And mixtures can be common things like tea or cordial. On your worksheet, you need to classify each of the following as elements, compounds, or mixtures. Rocks on the beach, copper, a mixture of jelly beans, salt, which is sodium chloride, diamonds, which are made up of carbon, lemonade, the neon gas found in signs, tea, sugar, silver, pure water, a salad mix, and an aluminium can. Part C, endothermic and exothermic reactions. So exothermic reactions are when a chemical reaction that gives off heat or energy to its surroundings. They include things like our explosions. The way I remember it, exothermic, EX, explosion, EX, or exiting, EX, is when our energy is being released. Endothermic is the opposite. So it's a chemical reaction that absorbs heat. Endo, EN, entrance, EN, or entering, EN. So energy is required to enter into our reaction for it to work. Some of our exothermic examples are things like combustion or burning, oxidizing, such as rusting, and neutralization reactions, which I had a look at in class, such as our volcano. Endothermic reactions are things like electrolysis, so when they copper plate or gold plate a metal. Reactions between like an acid and a carbonate, which can drop the temperature. And when things decompose, such as the experiment there with the copper, with the calcium carbonate and copper carbonate and carbon dioxide being produced, it requires heat initially to get the reaction to happen. So exothermic, endothermic, we've got endothermic on the left-hand side there because it's decreasing in temperature, and exothermic on the right-hand side. Sometimes you'll see energy written into our word equations as well. So we've got photosynthesis there, which is carbon dioxide, water, and energy, making glucose and oxygen. The energy is on the left-hand side because photosynthesis is endothermic and requires energy at the beginning. We've got respiration. So respiration happens in our cells, where it's basically the opposite of photosynthesis. We've got glucose and oxygen, and then making carbon dioxide, water, and energy being put out. And anyone who's ever done some physical activity will know that when your heart rate's up, you're respiring more, and your body temperature will go up because of that energy output. So that means that respiration is an exothermic reaction. On your worksheet, you need to classify the following as exothermic or endothermic reactions. We have photosynthesis, a hand warmer which you can crack and will increase in temperature, burning magnesium, adding sodium carbonate to an acid, so remember adding a carbonate to an acid, rusting of a car, an instant cold pack, one you crack and the temperature decreases, our volcano with bicarb and vinegar, our respiration happening in our cells, when we use electrolysis to copper plate something, when we're using a decomposition experiment, and combustion. So you need to work through your the handouts attached with this and return it to your lesson at the beginning of, or return it to your teacher at the beginning of next lesson, and you'll do activities based on how we do on the pre-test then.